Hello and welcome. This is Safa. In this episode, we explore how a disturbance observer can be combined with a sliding mode control to improve robustness against unknown ocean currents and model uncertainties. While a sliding mode control is already robust, it may still suffer under strong unknown disturbances such as ocean currents or wave forces. A disturbance observer or DOB helps estimate these unknown forces in real time so the controller can cancel them. The idea is simple. The sliding mode controller ensures tracking, while the DOB estimates disturbances. The final control input is the standard SMC law minus the estimated disturbance, which effectively cancels it out. We consider a simplified 2-degree of freedom AUV moving in surge and sway. Its dynamics are given by mass, damping, control input, and disturbances. The AUV is tasked with following a circular trajectory. The control procedure follows 4 steps. First, compute tracking error and sliding surface. Second, design the standard SMC law. Third, estimate the disturbance using the observer. And finally, subtract the estimated disturbance from the input. Okay, in simulation, we run 40 seconds of AUV motion with disturbances mode of sinusoidal waves plus noise. We compare two cases, poor sliding mode control and DOB-SMC using trajectory accuracy and RMS tracking error as evaluation metrics. The results clearly show that the DOB-SMC tracks the path more accurately than pure SMC. The observer provides a good estimate of the disturbance, and the RMS tracking error is reduced. To conclude, the DOB-SMC enhances the robustness of a sliding mode control against unknown ocean forces, providing a more reliable solution for real-world AUV missions. Okay, let's go MATLAB. Okay, here we define time, system dynamics, and controller parameters. You can see. And desired trajectory, disturbance. We add sinusoidal plus random noise disturbances in both direction. Okay. Simulation loop. Two controllers are simulated in parallel, pool SMC and DOB-SMC. For DOB-SMC, the estimated disturbance is subtract from the control input. Okay. You can see pool SMC control, DOB, system dynamic. update disturbance observer. And observer update, the disturbance observer updates its estimate at each time step using system dynamic. And finally result, we calculate RMS errors and plot the result for trajectory tracking, disturbance estimation, and position error. Okay, run this code. RMC position error. Okay, you can see figure here. Okay, that's it. Thanks for watching. This is Safa. We're learning together one concept, one line of code at a time.